Hey everyone, welcome back. So today we're going to be solving maximum depth of a binary tree. This is actually part of a tree series that I'm doing. And this is an easy question, and I'll be coding the solution in Java, but the concept and the logic is language independent. So if you're from any language, you can still follow through. Okay, so let's get started. The problem is maximum depth of a binary tree. Basically, what it's asking us is that you're given a binary tree, and you need to calculate the maximum depth of the binary tree. What is the maximum depth? It is nothing but is the number of nodes along the longest path uh, from the root node down to the farthest leaf node. Okay, so basically, what the question is asking us is that this is your root node, okay, and you need to return the length of the longest path from the root node to the leaf node. Okay, if you don't know what a leaf node is nothing but a node which does not have any children, right? Neither one nor two, right? So that is what a leaf node is. Okay, so you need to return the longest path from the root node to the leaf node, right? Now, this answer would be 3, right? You can have multiple answers. You can have this as well, but you can have this as well. Okay, but we need to return the maximum value, right? What is the maximum value? It is nothing but this path, or you can even consider this path, right? You can even consider this path. This is nothing but a maximum value. Okay, so one more thing to notice is that, see, the thing is, if by default, if it's asking you the maximum depth of a binary tree, right, you would be calculating the number of nodes, right? Nodes in that path, which is 3. But if you calculate the number of edges in that path, right? The number of edges is what? What is an edge, by the way? Edge is nothing but a line which connects 2 nodes, right? That is what an edge is. Simply, that is what an edge is, right? So if you see, there are only 2 edges, right? So if it's asking you to, calculate the height of a binary tree in terms of edge, in that case you need to be returning true. But if it's asking you to calculate the height of a binary tree or maximum depth of a binary tree, it's nothing but the number of nodes in the longest path of a binary tree. Okay, that's what it means. Perfect. Now let's think about how we can do this. Okay, let's break it down into sub problems. Okay, now I have the root node, right? Now for the longest path, what will I do? Right, now I don't know what the longest path is, right? What will I ideally do? I'll either go towards the left or I'll go towards the right. I'll have to calculate the path, right? Now I go towards the left. Okay, let's consider this path. Now what is your path? Maximum length. What is my maximum length? If I go to this, it's 2, right? Makes sense. My maximum length is 2. Okay, can there be a better answer? Right, of course, because you traverse only through one part of the tree. Okay, then what will you do? You'll go towards the next path. You go here. Okay, what is your answer? Okay, wait. Okay, we go to this path. Are we supposed to stop at this path and check what is the height? No, right? Because clearly the question is asking us to return the number of nodes along the longest path from the root node down to the farthest leaf node till the leaf node, right? So ideally, when would you calculate the maximum length? You would calculate the maximum length when you are at a leaf, right? Now what I do is, okay, I'm here. I cannot calculate the path. So what will I do? I'll go here, right? Now from here I've gone here. From here I've gone here. Yeah. Now this can be my path, right? Because you're going from the root to the leaf. What is my maximum length? It's 3. Is it greater than 2? Yes, it's greater than 2. So I'm going to update it. Okay, perfect. Are we done? No, we're not done, because there's one more path left, which is nothing but 3 to 7, right? Now we've reached from the root to the leaf node, right? What is our number of nodes that is there? It's nothing but 3, right? It's the same as the answer, right? So we don't have to update it. We can just return 3. So this would be our approach. So this is the approach that we're going to be following, right? Now, how do we do this? We're going to apply DFS, any order traversal. We can apply pre-order, in-order, or post-order. Just that we need to make sure that whenever we reach the leaf node, we need to make sure that, hey, is this greater than our maximum length or is this less than that? Based on that, we need to calculate, okay? But how do you know that you've reached a leaf node? It's very simple. Whenever you come to a node, right, you'll check, is my left null? Yes, it's null. Is my right null? Yes, it's null. Since both of them are null, I know for a fact it is my leaf node, right? Because what did I tell you about leaf node? Leaf nodes are nodes where it doesn't have any children. It doesn't have either one nor two children, right? So you cannot, so this would obviously be a leaf node, right? Perfect. So let's try this approach, and after this, I'll tell you how do we calculate the height based on the number of edges, right? It's just a simple change in the simple change in the solution, and I'll tell you that after we've coded the current solution. Okay, let's get started. Now, what will I do? The first thing that I need to do is I need to have something called as a maximum length, right? So I'll have something called as a max length, which will ideally initially be set to integer.min value. Perfect. Now here I can do one thing. I can have a return type as int, okay, and then I'll call this as recursion to keep it simple. And then what would this have? This will have nothing but the tree node, which is root. Perfect. Now, what is our base case, right? Whenever we write a recursive call, we always need to handle a base case because that is exactly when your recursion is going to stop. What is our base case? If we think about it, whenever we reached over here, right? Whenever we reached over here, right? At this point, okay, we know for a fact for this subtree, forget these part, okay, I'm talking about only this subtree, okay, though this does not have any nodes to it, but this itself is a subtree, right? That we know, right? What is the height of this subtree? Can I say that height of this subtree will be nothing but 1? I can say that, right? So when I've reached my null, that is when I've reached over here, okay, what is the height of this subtree? There is no subtree. So what do I have to return? What would be the height? Height would be nothing but 0, right? It makes sense. Height would be nothing but 0. So whenever my root is null, can I say that the height of that is 0? If root equals to null, I'll just return 0. Perfect. Good. Now, what is my next case? I need to calculate my height, right? I need to calculate my height. Before calculating height, what do I have to do? I have to check if it's a leaf node or not. Only then I'll be checking what my height is, right? Yes. Okay. So now we need to check the depth of the tree, right? Okay. So I will have two values, right? One is left height, and then I'll call it right height. Okay, and then I'll have something called as int right height. Okay, now what would be my left height? It'll be my height of the left subtree, right? So what will I do? I'll call recursion of root dot left. Perfect. Makes sense. What would be my right height? I'll call recursion of root dot right. Now comes your main logic. Okay. Now tell me something. If this is my tree, right? If this is my tree, 3, 9, 20, 15, and 7. What would be my height? If I have to calculate the number of nodes, wouldn't it just be height from here to all the levels, that is this level, this level, this level, all the levels of my tree. How many levels do I have? I have 3 levels, right? So can I say that my height would indeed be the levels, the number of levels on my tree, right? Perfect. The maximum height, obviously, right? Because let's say that you have, something like, 20, and then you have 30. Okay, this, let's say that this becomes a skew tree. Okay, in that case, if you think about it, what would be my height? It'll go from 3. Wouldn't it just go from 3 to 30? Makes sense, right? And what would be my level? This would be my level 1, this would be my level 2, this would be my level 3, this would be my level 4, this would be my level 5, right? And what is the count now, right? Count will be nothing but 1, 2. If I'm following this path, let me mark the path first. If I'm following this part, that is this part, what would be my height? It'll be nothing but 1, 2, 3, 4, and 5. 5 is my answer, right? Makes sense. So now comes the tricky part. Now comes the logic. Okay, how do I know that 5 is my height? You're saying that, hey Siddharth, you're checking the left height and the right height. Okay, at left height, okay, let's consider this as the answer. Okay, let's consider. Okay, let's consider 3. For 3, what are we doing? We're calculating the left height and we're calculating the right height, right? Perfect. What is the left height? Left height is 1. So ideally this would have returned back 1, right? Now what is my right height? Right height is nothing but 1, 2, 3, 4, and 5. So this would have returned back 5. So can I say that my height, my final height, would be nothing but max of my left height and my right height plus 1. Makes sense, right? Just one mistake. This would not return 5. This will actually return 1. This will actually return 4. Why 4? Because you're calculating the height of this subtree. You're not including 3. You're only calculating the height of this particular subtree. So the height of this particular subtree is 4, right? So whenever it comes over here, this will return 4 and this will return 1. Okay. Now can I say that my answer, final answer would be max of left height, comma the right height plus 1, right? Why plus 1? Because I'm including my 3 as well, right? Perfect. Now let's try this out for more nodes. Okay. Now I've tried it out for 3. Let's try it out for try it out for 20. What will be my height of 20? If I'm only considering 20, let's forget this part. Let's only consider 20. Okay, from 20, what would be my height? This would return 1. Perfect. What would this return? 1, 2, 3. This will return 3. What will be my height of only this subtree? What would be my height? It'll be nothing but max of left subtree, comma the right subtree, which is nothing but 3 plus 1. Why 1? Because we're including 20 as well, right? Now I can say that my height of the tree will be left comma right, max of left comma right plus 1, right? Perfect. That's exactly what I'm gonna do over here. What I'm gonna do is, see, the thing is, I have a global variable over here, max height. Ideally, I don't need it. What I thought is I'll update the max value directly, and then I'll return the max height. But actually, I don't need this, right? Because your recursive call itself is returning you the height of the entire tree, which is nothing but your max height, right? So here, can I return math.max of left height, comma right height. Okay, right height plus 1. Perfect. I can say this, right? So I'll return math.max of left height comma right height plus 1, right? Perfect. Now, when I'm returning plus 1, this will return back. Okay, now what do I have to do? I just have to return this value, return recursion of root. Okay, let's run this. Okay, I made a mistake. Match dot. Oh, sorry, spelling mistake. Okay. Perfect. Now, we got the answer. Let's try to submit this, and let's see how it runs. Okay. Perfect. Okay. Now, let me tweak the question a bit. Okay, what I'm saying is that for this node 3, 9, 20, 15 and 17, 20 and 30, what my question asks is that you need to calculate the maximum number of edges from root to leaf node. Again, I'm not asking you to find the maximum number of nodes. I'm asking you to find the maximum number of edges. What is an edge? This is an edge. This is an edge. This is an edge. This is an edge. I'm asking you to find the maximum number of edge from root to leaf node. Right? Let's think about it. What is the maximum number of edge for this particular subtree? Maximum number of edges 1. Right? What is the maximum number of edges for this particular subtree? It's nothing but 1, 2, 3, right? 3 and 4. I need to include this as well. It'll be 4, right? So what would be my answer? My answer would be nothing but 4, right? Makes sense. Now, how would our logic change? Right, it's the same thing as returning the number of nodes, maximum number of nodes from root to leaf, right? Now, what I have to return is the number of edges from root to leaf. Okay, we observe that from the number of edges from root to leaf is nothing but 1 less than the maximum number of nodes, right? What is the maximum number of nodes? Maximum number of nodes was 1, 2, 3, 4 and 5. This is the maximum number of nodes. But what is our maximum number of edges? It is 4. So can I say that my maximum number of edges would be 1 less than my maximum number of nodes? I can say that, right? Now, with this, keeping this intuition in mind, how would our logic change? It's nothing but a simple change. What I'm going to do is, when my root is null, I'm going to return -1. I'm not going to return 0. What is happening when I was returning 0? What was happening when I was returning 0? It was coming over here to 9. Oh, sorry. It was coming over here to 9. Then it'll go towards the left. This is null, right? So this was returning 0, right? Then it'll come towards the right. This is null. So this is returning 0. Now after left and right, what I'm doing is I'm calculating the max of that, and then I'm returning +1 of that. So I was returning 1, right? I was returning 1, right? Same thing over here. This was null, this was null. I was returning 0, I was returning 0, and from here I was returning 1, right? This was again null, so this was returning 0, I was returning 2. This was null, I was returning 0 from here I was returning 3. Okay, now over here again, this is 1, ideally this is 1, this is 1, this will return 1, this will return 3, so I was returning 4, and 4 I was returning +1, 5, right? Now with my edges, how will it be? It's the same thing, it's just that I'm returning, let me take this example itself, 9, 20, 15, 7, uh, 20 and then 30. What is that? What am I returning now? When it's 9, this is null, so this will return -1, right? Over here this will be x, null again. I'm denoting x as null. This will return -1. So what am I returning from here to here? Max of left comma right plus 1 is what I'm returning, right? In my logic also, I'm returning max of left comma right plus 1, right? So when it's returning max of left and right, -1 and -1, max is -1. What will it return? It will return 0, right? Now I'll come here again. This will do the same thing. This is okay, this will actually return 0. This will return -1 -1. This will return -1 plus 1 will be 0. This is again null. 0 is max, plus 1 will return 1. Now plus 1 will be returned 1. This is also null, which will be -1 again. Max is 1. 1 plus 1 will be returned as 2, right? Now 2 and 0, max is 2. I'll be returning 3, right? 3 and 0, max is 3. I'll be returning 4. This will be my answer, right? So I can say that the number of nodes, the maximum number of edges a tree in this tree that this tree has is nothing but 1, 2, 3 and 4, which is nothing but my answer, right? So if the question is tweaked a bit, asking you to find the number of edges from maximum number of edges from root to leaf, all you'll have to do is replace this 0 with -1. That is it, okay? But since this question is not asking us to do that, we have done it with 0, okay? Perfect. I hope you understood the solution. If you did, and please subscribe, it'll mean a lot to me. Thank you so much.